We're out here at a job site on a nice fall day, and I'm with my professional colleague, Paul Thompson here, and I'd like to introduce him. He's given me a lot of support over the years. Known Paul for about 6 years, I guess we figured out. And Paul, give us a little bit of your background.
Well, I started out in the coatings industry in high school and worked my way through college working for Sherwin-Williams. Spent 15 years with Sherwin-Williams. Then I became a product manager for a large company. Then moved on to Valspar Corporation, where I was the general manager of their industrial flooring division based out of Chicago.
Yeah, what are you doing now?
Since 1999, I've been an independent consultant working with various property owners and contractors across the 5-state area and now nationally, looking at flooring and concrete buildings.
Yeah, no, I always come when I'm calling you for one of your opinions on the floors that we do. I know I catch you at architects and specifiers and places like that, and you have to call me back when I've got a need for a little information on a technical issue that I have with a floor. It helps me out a lot, I'll tell you that. Back about 6 years ago when you and I first met, I was making a change for products because the people that were producing my product were, well, frankly, they were undercapitalized and were going out of business, and so I was looking for the best that I could find. And I don't know how I found you. I guess you were about that time making a transition to a distributor locally, and they suggested that I confer with you about the products I should use to have top quality product. And you recommended to me an epoxy flooring system and then a polyhybrid top coat system. And we've been doing that successfully for all those 6 years that I've been doing it. And tell me a little bit about how you got to the epoxy side of the business.
When I was working with Valspar in the industrial flooring division, we manufactured a wide range of flooring products, epoxies, urethanes, all different types of floor technologies. In the commercial area, in commercial buildings, we always put together the best products for the job, and usually it's a combination of technologies. Architects, engineers, and large commercial property owners are looking for the product that will meet a wide variety of uses and durability. So by looking at the floor, combining technologies, we're able to give the owner the best group of products for the jobs. So epoxies, for example, have better adhesion, build better, fill better, are harder. Urethanes are more scratch resistant, UV stable. So by combining those two products, we're able to give the owner the best long-lasting product for the job.
Yeah, and over my time, I've early on addressed a new product which was called polyaspartic. How does that fit into this framework of urethanes and epoxy?
Polyaspartics are cousins, let's say, to polyurethanes. They're a faster setting urethane. They have the same chemical background, but they're two components, so they cure quicker, there's less solvent, less odor, more UV stable. So they're really a next generation floor coating that gives the owner a durable, long-lasting floor.
When I was using the polyaspartics early on and I was introduced to that product line, I installed about a dozen floors and I wasn't really, frankly, very happy with them. And so I had to, frankly, the only floors I've ever had to redo is a result of using that product. And I switched back later on then to an epoxy base and a polyhybrid with some polyaspartic in it, top coat. And then I've had success with that. Can you comment on that combination? Does that seem to be the right way to go? At least you've recommended it to me, and I'd like to know why.
Well, no two garage floors are the same. So when you look at each garage floor, an evaluation needs to take place. So normally in Minnesota here especially, we have a lot of moisture problems from the slab. Kind of the downside to using a polyaspartic directly to concrete is that they can be moisture sensitive. So one of the advantages to epoxies are they are somewhat moisture tolerant. And if there's a doing a test on the floor to see if there's a higher level of moisture drive or moisture content, the epoxy is a better choice because of the adhesion and the tolerance to some moisture. So by putting the epoxy on first, you're getting something that you're not going to have moisture type pop-offs that sometimes are associated with urethanes directly to contact.
You know, I noticed that when I've ever looked at any commercial floor bidding information, they always are speccing out epoxy-based floors. I've never seen them really spec out polyaspartics, and I've always sold that idea to the customers that we deal with, that still the good old tried and true epoxy base is still the best. Is that a fair statement to make?
Well, when you're looking at it as a primer filler, yes it is. So in the commercial industry, most of the commercial flooring manufacturers test their products under ASTM. And ASTM requires third-party validation of testing.
Association of
It's a testing agency that the architects and engineers use as a base. So a lot of times when you hear on the radio or TV that our product does this, our product does that, take a look at the data guide. On the data guide of the manufacturer, they should have ASTM testing of the materials. So for example, if you look at the ASTM testing for adhesion for epoxy, it is much greater on the epoxy side than it would be on other type urethane top coats when applied directly to concrete. So look at that ASTM testing. It's a good way to evaluate the properties of the different products.
Yeah, well, we're out here on a nice fall day, and we're looking at the guys in the background here doing a floor for a customer of ours out here in Delano. And, you know, it's a comfortable day in the middle of October and long term. I don't know if we have any more to say about our products. We have used elastomerics. Tell me a little bit about elastomerics.
So elastomerics are usually fall into the polyurethane category, where they're urethanes. So we use elastomeric or deck coatings when there's a lot of movement in the slab. In Minnesota here, we have a lot of precast garage floors or spancrete where there's an occupied area below. Polyurethane deck coatings were developed to coat, you see them a lot of times in parking ramps where you have a lot of bounce and movement. So we're able to waterproof these spancrete floors, span the crack, and the elastomeric will move with the crack. Again, an ASTM test will show you the elongation and recovery of the polyurethane coating. So generally they'll be in the 600 or 700% range where they'll move with that crack and waterproof that floor to keep the water out from down below.
When we go out to a floor situation, we kind of look around the surrounding terrain to get an idea of the geography, the location. Like, for instance, if we're close to a swamp or a low-lying area, that's when we are looking for hydrostatic pressure, water coming through that floor, and then we have to think about water mitigation systems. And that happens not often, but occasionally. And tell me a little bit about that, expand on that, because we've used the water mitigation systems in several settings, and it's really worked out well for us.
Well, water mitigation systems were developed several years ago, and it's an evolving science and an understanding of what causes it. It can be vapor and or water. So today we're near the Crow River, so we did a Tramex meter test on the floor just to make sure that we were within standards. The Tramex meter, it measures the moisture in the top 1 inch of the concrete. Less expensive meters can measure just the top of the concrete. We recommend the Tramex meter because you're measuring the top 1 inch, which gives you a better idea of what is going on in that slab. So if you have a concrete floor with a lot of pop-outs and spalling and things like that, it's a must. So we recommend the Tramex meter be used on every project where there's any chance at all that we'd have moisture drive. It gives you a readout of a number. If it's above that number, then we need to do a moisture mitigating system so that the finish coats will adhere well to the concrete. When you have a moisture problem in a concrete, the concrete actually will fail, taking the top coats with it. So anytime you're looking at a garage floor to be coated, we recommend a moisture test be done.
You know, you mentioned something about these pop-outs, and pop-outs, I call them divots. They look like a little ice cream cone formation that goes down to a sedimentary rock in the bottom of it. And you can actually see that little pebble, and that pebble seems to get some water in it from the concrete, and it freeze thaw over the winter. It pops it out. As you say, it takes the coating with it. And it happens in a small number, I'd say about less than 2% of our floors that we see that, and we have to go back out and service them. And it's a headache for everybody. But nonetheless, why does the concrete in Minnesota have that sedimentary rock in it? Is that an engineering specification, or is it just a part of the business?
It's part of the business. They mine gravel and aggregate and things that go into the concrete. There are industry standards. Looking back 10 or 15, 20 years, the standards weren't quite as high. The concrete manufacturers try to regulate that, but every once in a while you get some bad aggregate or soft aggregate. Less today than there was 30 years ago, but it still happens.
Yeah, that's my experience. We deal a lot with repairing of old floors, 30, 40, 50 years old. That's kind of what we have to deal with. But nonetheless, concrete is concrete. Do you recommend people using like granite fines in concrete?
The concrete additive business is kind of a separate division or separate group of companies. There are different industry standards depending on the use of the concrete. So it's always best just to do the test, and that will take care of that type of situation of the pop-outs usually. It's not a 100% guarantee, but it's a pretty good preventative measure.
One of the things you've mentioned about concrete is that, you know, what we do, and you've really advised us in the way to do this, is to do the proper preparation. And we grind all floors with a grinder that gives us I think there's a standard, a CSP 2 or 3 that we're looking for a kind of a grit level, an edge profile on that concrete floor. So we grind them, we trowel in a material on all of the spalling and the divots, and so then we regrind it again, and then we put the epoxy base down and broadcast the flakes into them. So that's the steps that we use in preparation. We think it's necessary. We know of, in the older days, they used to acid etch and do some cleaner solvents, but they never have been adequately prepare the floor. Have you seen other things that, in your experience, that are the ways to prep a floor?
When we look at jobs that don't turn out right, the number one reason would be improper preparation. So the companies that I work with, we require proper preparation, and we do have a standard for that. Like Ron indicated, it's a CSP. It's a range of from 1 to 10, and generally you need that. And the only way to effectively do that is with mechanical means. Things like acids and can be affected. If there's an old sealer on there, they don't work. And if you don't have the proper profile, it really doesn't matter what product you put on there, it's going to fail. So in your evaluating of garage floor systems, probably the most important thing is what is the preparation? Are they going to bead blast, shot blast, or diamond grind? Really needs to be one of those methods to get that rough feeling, almost like a rough sandpaper, so that that aggregate is exposed and you're removing any of the soft paste and latents off the top of the concrete, which can cause bond failure down the road.
And then we go through that process and then get the coating system down, and we broadcast the flakes, and then we come back on the second day and we do the job of scraping them up and getting them all trimmed up the way we want them. Then we put our top coat on, and we put an additive in the floor surface so that there's a slip resistance. And when we're done with that, the guys are done, and then I have the job of coming out the day after and looking at every floor, because I want to be sure the quality is absolutely retained for the integrity of the floors that we put out. We guarantee our floors. I want to know what we're doing and delivering. I want the customer happy.
Another reason for the evolution in basic polyurethane chemistry was the lowering of solvent standards within the United States by various governmental agencies. Manufacturers have taken out solvent in a lot of the products. Another thing was speed. Some of the old polyurethanes would take a day to cure, which caused delays in projects. So polyaspartics, polyureas were developed to speed up the curing cycles and lower the solvent used in the products. They also added improved abrasion resistance. So by marrying polyurethane, polyaspartics, polyurea technologies with the epoxy, we were able to get the best of both worlds.
Yeah, when I was focusing on was, the fact that the standards were California standards, frankly, that migrated throughout the United States. Solvent-based products were becoming challenged by the California standards, and therefore I was looking for 100% solids products, 100% solids in epoxy and 100% solids in our top coat. And so that's what I was wanting to deliver, because I didn't want any of the flash off of these VOCs, volatile organic compounds, that are solvents that are like, well, let's characterize it to like turpentine in oil-based paint. It flashes off, it's not on the floor. So a solvent goes away, it flashes off and evaporates. And now you have less on the floor. And that was something I did not want to have in our product delivery. And that's why I migrated to exactly where we are.
So Ron came to me with those challenging standards of 100% solids, durable finish. So we were able to hook Ron up with the two largest flooring manufacturers in the world, one for the epoxy side, one for the urethane side. So we're now using 100% solids epoxy, 100% solids top coat. So there's no harmful odors, fast cure, and durable results. So in the past, we were using products that were 60% solvent, for example, and we had to wear masks to apply them and things like that. So new day, better products, new technology, better result for the owner.
And that's why I went in that direction, and I've been very happy that we did. And I use as a point of differentiation, yes, it does take us a little longer to do the job. It takes us a couple days, sometimes 3. But we believe that we get the best of both worlds and deliver the right kind of product to the customer. Well, Paul, I really appreciate your taking the time out here at the job site out here in lovely Delano, and it's been a pleasure to talk with you and get to recapitulate the background that we use in our study of garage floors and how we do the job and consistently apply the best quality products that we can have. Thank you for your time.
You're welcome.